Today we will see our second application of derivatives, derivative as a rate measure. If y is equal to f of x is a given function, then a change in x from x1 to x2 is generally denoted by delta x. We generally denote by small increment in either x or in y. If there is a small increment in x, we denote it by delta x. Or if there is a small increment in y, we denote it by delta y. As here y is a function of x. So y depends on x. And x is changing from x1 to x2, means that there is a gradual change in x, the variable x, it is delta x. So because of that change, the corresponding change must be there in y, because y depends on x. So what is change in y? It is delta y. So f of x2 minus f of x1 is the change in y. Now then what we will do? We will take the ratio of this increment in y divided by increment in x, that is delta y by delta x is equal to f of x2 minus f of x1 upon x2 minus x1. Okay, this ratio is called as a average rate of change with respect to x. What is called? Average rate of change with respect to x. Now, this can also be interpreted geometrically as the slope of the secant line joining the points P, x1, f of x1 and Q, x2, f of x2 on the graph of the function y is equal to f of x. Now, consider the average rate of change over the smaller and smaller intervals by taking x2 approaches to x1. Whenever this x2, what happened, the x1 changes to x2, so x1 approaches to x1 increased to reach x2. Now what we will do, we will make that difference is smaller and smaller and smaller. That means x2 is approaching now to the original point x1. In this case, this increment delta x, this increment goes to 0, it approaches to 0. The limit of this average rate change is called the instantaneous rate of change of y with respect to x. What is called? Instantaneous rate of change of y with respect to x when x is equal to x1. Okay, and is interpreted as the slope of the tangent to the curve y is equal to f of x at the point x1 f of x1. Okay, so forget this all, just keep in mind limit of delta y by delta x tends to 0, limit of f of x2 minus f of x1 upon x2 minus x1 as x2 tends to x1. We recognize this limit as derivative of f of x at x is equal to x1. In 11th standard, you have studied this definition derivative by using the first principle. In that, here x2 is x plus h, okay, and x2 minus x1 is h. So limit of f of a plus h minus f of a upon h as h tends to 0 is nothing but the derivative of the given function. Now, the interpretation of the derivative of f dash at a is the instantaneous rate of change of y with respect to x when x is equal to a. That is, the other interpretation of is f of x at f dash at a is the slope of the tangent at y is equal to f of x at a and f of a. So, what is the rate of change of one variable with respect to other variable? We will see this rate measure by using this example. What is the example? A stone is dropped into a quiet lake and waves in the form of the circles are generated. Okay, the radius of the circular wave increase at the rate of 5 centimeter per second at the instant when the radius of the circular wave is 8 centimeter. How fast they are enclosed, the area is enclosed in increasing. So you understood this problem? There is one lake. In that lake, I throw a stone. I throw a stone in that water. What happened? A circular ripples are generated. The circular waves are getting generated. Okay, so and these moves towards the bank, towards the end of this lake. So at radius, the radius of the circular wave, this is the radius of the first, this is the radius of the second, this is the radius of the third, and so on. This radius is increasing at particular rate. What is the rate? 5 centimeter per second. That means this radius is increasing at the rate of 5 centimeter per second. In 1 second, 5 centimeter. In another second, it becomes 10 centimeter. In another 1 second, it becomes 15 centimeter. So likewise, it increasing. So, and what we have to do? We have to, at the instant when the radius of the circular wave is 8 centimeter, what is the rate of area enclosed is increasing? That we have to find out. Now what to do? Let R be the radius and A be the area of the circular wave. Okay, R is the radius and A is the area of that particular circular wave. So A is equal to pi R square. This is the formula. Differentiate with respect to t. Now dA by dt is equal to, now here there is a t. Is there any t? No. Pi r square doesn't contain any t. So firstly, we have to differentiate these with respect to r and then r with respect to t. This is our equation number 1. But it is given that the rate of change of the radius is 5 centimeter per second. That is dr by dt is 5 centimeter per second. Okay, and we want to find the area when the radius is 8 centimeter. So put these two values in this equation number 1. What you get? 2 pi into 8 into 5. That means 80 pi. What is the answer then? Hence, when the radius of the circular wave is 8 centimeter, the area of the circular wave is increasing at the rate of 80 pi centimeter per square. Okay, so while radius is increasing 5 centimeter per second, the area is increasing at the rate of 80 pi centimeter square per second. Now what is the next example? Water is being poured at the rate of 36 meter cube per second into a cylindrical vessel of base radius is 3 meters. Find the rate at which the water level is rising. So let R be the radius of the base and H be the height, V be the volume of the cylindrical vessel. We are pouring water in that particular vessel at the rate of 4 pi by 3 centimeter square per second at any time t. R, V, H are functions of t. So what is the volume of that cylindrical vessel? Pi r square h. So V is equal to pi. What is R? R is 3. It is given. Radius is 3 meters. H we don't know. So the V is 9 pi h. Now differentiate with respect to t. dV by, here there is no t. Again we have to differentiate with respect to h, then h with respect to t. So dV by dt is 9 pi dH by dt. So what is dH by dt? Then dH by dt is 1 upon 9 pi dV by dt. This is the equation number 1. Why I have simplified for dH by dt? Because we want to find the rate at which water level is rising. Water level वाढण्याची rate आपल्याला काढायचा आहे. So height, the change in height we want to find out. So dH by dt take outside. So what is given now? Rate of change of the volume is given dV by dt is 36 meter cube per second. So in 1 second it is changes by 36 meter cube. Also the dH by dt is 1 upon 9 pi into 36 is 4 upon 5. So dH by dt is also 4 upon 5. So water level is rising at the rate of 4 upon pi meter per second. So with these initial conditions, the water level is rising at the rate of 4 by pi meter per seconds. The next example, the volume of the spherical ball is increasing at the rate of 4 pi cubic centimeter per second. What is the rate at which the radius of the surface area are changing when the volume is 288 pi cubic centimeter? Let R be the radius, S be the surface area, and B be the volume of the spherical ball. Now radius is R centimeter. So what is the volume? 4 by 3 pi R cube. And what is its derivative with respect to T? 4 by 3 pi as it is. Derivative of R cube with respect to T is 3R square dr by dt. Now what is given? It is given that the volume is increasing at the rate of 4 pi cubic centimeter. So dV by dt is given 4 pi cubic centimeter per second. So put that value. This 4 pi, this 4 pi will cancel. This 3 is also cancelled. So dr by dt is 1 upon r square. So rate of change of the radius is 1 upon r square. Equation number of 2. Now the volume, when the volume is 288 pi cubic centimeter, so 4 by 3 pi r cube is equal to 288 pi. So r cube is equal to 216. So which implies r must be equal to 6 because cube of 6 is 216. So we get dr by dt is 1 upon 36. That is rate of change of the radius when the volume is increasing is 1 upon 36 centimeter per second. So the radius of the spherical ball is increasing at the rate of 1 by 36 centimeter per second. Now what is the surface area of the given spherical ball? 4 pi r square. Differentiate it with respect to t. We get ds by dt is the rate of change of the surface area and is given by 4 pi d by dt of r square. It is 2r dr by dt. So in that, now when it is given that the radius is 6, radius of the when the volume is 288 pi, the radius is 6. So r is equal to 6 and dr by dt just now we have find out 1 by 36. Put those values in this equation. You will get ds by dt is 4 pi upon 3. So the surface area, the rate at which the surface area is increasing is 4 pi by 3 centimeter square per second. म्हणजे सेकंदाला 4 pi upon 3 centimeter square एवढा एरिया वाढतोय. Let us see this example, fourth one. A man of height 188 centimeter, 180 centimeter is moving away from the lamp post. कुठेतरी एक लॅम्प पोस्ट आहे, तिथून तो माणूस बाजूला मूव्ह होतोय. तो बाजूला मूव्ह होण्याचा जो रेट आहे तो किती आहे? 1.2 meters per second. So the man is moving away from that lamp post at the rate of 1.2 meters per second if The height of the lamp post is 4.5 meters. Find the rate at which his shadow is lengthening. Shadow किती प्रमाणात वाढू राहिली. And the tip of the shadow is moving. तो टिप ऑफ द शॅडो जो आहे तो किती प्रमाणात मूव्ह होतो हे आपल्याला. So the tip of the shadow is moving. Okay, observe this figure. This is your lamp post. एक खांब, विजेचा खांब, इथं एक लॅम्प लावलेला आहे. हा एक माणूस आहे जो त्या लॅम्प पोस्ट पासून आता थोडा बाजूला जाऊ राहिला आहे ॲट द रेट ऑफ 1.2 मीटर पर सेकंड. तर तुम्हाला काय करायचंय, ही जी शॅडो इज लेंथनिंग, त्याची जी आता हा इथं माणूस असेल, इथं लॅम्प असेल, तर ही जी एक्स दिसते ही काय, त्याची सावली आहे. तर ही सावलीची लेंथनिंग कशी लांबते त्याची रेट तुम्हाला विचारलाय. आणि दुसरा, द टिप ऑफ द शॅडो इज मुव्हिंग, म्हणजे ही जी शॅडो आहे याचं टिप म्हणजे टोक हे किती प्रमाणात, किती स्पीडमध्ये पुढे जाऊ राहिले. Shadow, the length, the tip of the shadow is moving. So let OA be the lamppost, OA be the lamppost, MN be the man, MN be the man, MB हा काय, X म्हणजे काय, लेंथ ऑफ दी शॅडो, त्या माणसाची शॅडोची लेंथ. आणि OM be the Y काय आहे ते, डिस्टन्स ऑफ द मॅन फ्रॉम द लॅम्प पोस्ट ॲट टाइम t. Now what is given? The man is moving from the lamp post at the rate of 1.2 meter per second. X and Y are functions of t. हा जो माणूस आहे तो ह्या लॅम्प पोस्ट पासून 1.2 मीटर पर सेकंडनी मूव्ह हो राहिला आहे. त्याच्यामुळे हा एक y आणि y हा कोणावर डिपेंड आहे, त्या टाइमवर डिपेंड आहे. सो x and y आर द फंक्शन, टाइम फंक्शन्स. सो what is given, dy by dt, rate of change of y is given 1.2. When 1.2, the rate at which the shadow is lengthening, rate at which shadow is lengthening is dx by dt. dx by dt म्हणजे ते सावली लांबण्याचा रेशो. तर आपण dx by dt, rate of change of x with respect to t, dx by dt. So and this b is the, what is b? B is the tip of the shadow, शेवटचं टोक, शॅडोचं, सावलीचं शेवटचं टोक, that is called tip of the shadow. आणि त्याचं डिस्टन्स किती आहे या लॅम्प पोस्ट पासून, तर हे डिस्टन्स आहे x आणि y, x plus y is the distance of the tip of the shadow from this lamp post. So using the geometrical formula, this x upon 1.8, x upon 1.8 is equal to x plus y upon 4.5. दिले. height of the lamp post is 4.5. ही जी लॅम्प पोस्ट आहे याची हाईट किती आहे, 4.5. आणि माणसाची हाईट किती आहे, 180 सेंटीमीटर. सगळं मीटर मध्ये आहे आणि हे माणसाची हाईटच फक्त सेंटीमीटर मध्ये आहे, म्हणून आपल्याला ती मीटर मध्ये कन्वर्ट करायची आहे. दॅट इज 1.8 मीटर. ही 4.5 मीटर, ही 1.8 मीटर. सो x upon 1.8 is same as x plus y upon 4.5. This is the result from geometry. So cross multiply and simplify, you will get 20x is equal to 80y, that is x is equal to 2 by 3y. आता मी x च का काढला, y का नाही काढला, कारण मला पाहिजे dx by dt, कारण माझ्याकडे dy by dt ऑलरेडी आहे. सो डिफरन्शिएट विथ रिस्पेक्ट टू t, dx by dt is equal to 2 by 3 times, what is the derivative of y then, dy by dt. And what is the value of dy by dt? dy by dt is 1.2. Simplify, 0.8 meter per second. So the rate at which the tip of the shadow is moving is given by d by dt of x plus y. So dx by dt plus dy by dt. dx by dt is 0.8, dy by dt is 1.2. So take their addition, you will get 2 meter per second. So the shadow is lengthening at the rate of 0.8 meter per second, and the tip of the shadow is moving at the rate of 2 meter per second. Okay, so this is all about the rate measurer.